my name is Giacomo. If this works, no, it doesn't. Well, my name is Giacomo. It comes without saying. I do love functional programming, part of the Gleam core team. But surprisingly, despite this being the Gleam track, I'm not here to talk about Gleam, but about databases. So let's get started with that. Now picture this, maybe you're building some sort of real-world application. Maybe your business and marketing department want you to do some data wrangling because they need to make beautiful graphs and reports, because of course they do. Or maybe you're building something for your friends. Well, I do love reading. I have a book club with my friends, so being a nerd, I had to do something with all the data I was gathering, and I'm putting it in a database. We have books, they have a title, we rate them from 1 to 5 stars, they have genres, and much more. And really, it doesn't matter what you're building, because if you are talking to a database, well, that comes with the age-old question of how do I do that? And the answer might take entirely different looks. So you might be tempted to be writing row SQL, or go the exact opposite end of the spectrum and abstract it away. Use fancy tools and frameworks, like ORMs, for example, query builders, things that try and hide the fact that SQL is even there. So you can ignore that you're doing queries to the database. You can just write in your favorite language of choice. And well, as developers, when it comes to making these decisions, well, we love saying something along these lines, that a developer should be a polyglot, that we should be using the right language for the job. We love saying that because we know the right language for the job is, of course, Gleam, Elixir, Erlang. We love those. But, well, I'd argue that when it comes to talking to the database, well, the right language for the job is SQL, the language of the database. By sticking to SQL, to plain old SQL, we see some really nice advantages. One, we are being explicit. It's not being abstracted away. So we can see if we're implementing some workflow using one, a couple, 10, hundreds of queries maybe. And so we can immediately see if we're making many round trips to the database. And that's the number one thing you want to be careful about if you want to make your application fast and responsive, because we don't want to waste a lot of time doing round trips to the database. We want to squeeze out as much as possible from a single query, for example. Well, if we are the ones writing those, they are not magically generated at runtime, well, we can see we're being inefficient. Also, we can avoid common pitfalls, like overfetching, the famous select star that is fetching loads of data from the database, making things unnecessarily slow. Because we are writing the query, we can see that there's a select star in there. It will not pass code review because we see it's there, and we can make it better. So it's not magically making our applications faster. Of course, there's no beating a bad architecture, but it's kind of nudging us towards a pit of success, where we know we're building something, we can reliably tell how it's working and what kind of work is going on under the hood. Also, by sticking to SQL, we can tap into its full potential, and SQL is quite the powerful language. Take this query, which is doing something quite remarkable for such few lines of code. So what we're doing here is we're building a ranking of books, where each book is going to be assigned a number, a position, based on its average rating inside its genre. So the best science fiction book is going to be number 1, number 2, 3, and so on. And really, it's impossible to catch up with 20 years of SQL evolution in 20 minutes. Do check out Modern SQL. It's an amazing resource for that. SQL nowadays can allow us to do so much more than just querying relational data. It allows us to deal with unstructured data, JSON, XML, tree-like data, graph-like data in the latest standard. It's really mind-blowing. So this comes with a question, though. If SQL is so good, where is all the SQL? Why isn't everyone using it? Why do we feel like we need to abstract it away? Well, when it comes to writing SQL in our applications, it might look something like this. And here I'm using Gleam, but really, if you squint hard enough, it would look basically the same in diametrically opposed languages like Java, for example, if you've ever had to do that. So what we're doing here is we are writing our query as, well, a string in our language. That is the query we want to run to the database. And then we need an additional piece of code, something to bridge the gap between the relational world of our database, where we have tables and columns, and the world of our application, where we have tuples, dictionaries, lists, or whatever kind of data type we might be using. And so here, we're telling it that the first column, the ISBN, well, that is a string, and the second one, again, contains strings, the book title. Then, after decoding those two pieces of data, we're using those to build a book. If you're not familiar with Gleam, this is a custom type. You can think of it as a tagged tuple in Erlang or Elixir. And so far, so good. This might look totally fine and reasonable. However, if you start writing even more than just a single query, you'll start noticing all kind of little annoyances. Say you're adding an additional column. Say you're switching columns around. This looks off, though I guarantee you if something can happen, it will happen. Someone will switch those two columns for some reason. And now your code is slightly wrong. The decoder is no longer right for the query. And there's no guarantee that someone or something is reminding us to update the two things in sync. And now we start seeing errors, because this query is not returning just two columns that are strings, but three columns, one of them is a float, and so on. And when do we start seeing those errors? Well, as we run our code. So if we were good and diligent and we've written tests, we're going to see our tests fail. If we didn't, well, that's going to pop up in production as we ship our code. So we started from a place where we were thinking about the data we wanted, and ideally, in an ideal world, we just fetch and use the data. To do that, we need to write some SQL. But then comes the tricky part. We need to write some glue code, that piece of code that is bridging the gap between the database and Gleam or the language we're using. And then finally, we use the data. But glue code, it's in the name, it's sticky, it calls for more glue code, so you'll be stuck writing more and more. And then you start finding bugs and errors because somehow your query is evolving, your data shape is evolving as well, the database changes over time. And so you need to go back to writing SQL and then go back to writing glue code. It's just a mess. No one wants to do that. And that's why we feel like we need different tools. So what should we do? Should we just give up? As nice as SQL is, it's not meant to build applications. We should be using other languages, ORMs, for example. Well, you know the title of the talk, you do not need an ORM. So it could be really nice. What would it look like to embrace SQL? To actually stick to plain old queries and at the same time expect a nice developer experience, not string wrangling and glue code. What if calling a SQL query was as simple as calling a function? We are functional developers. That's our bread and butter. We call a function, we start pattern matching on it, we do something with the data we get back, and that's what we want to do. We want to build things. So in order to show you that, I would like to showcase a library I'm the author of called Squirrel that tries to do exactly this. I think the best way is to actually have a look at the code to get a feel for what this is like. So let's dive into a live demo. So here we're building some simple-ish Gleam application, a web server that's serving this ranking of books. That's just a web page with some HTML. So we want to write that query, and again, Squirrel will let us write it in a SQL file. And so the first really nice thing is, well, that is a SQL file, so we get syntax highlighting. It's no longer a string in our code. We get to use the tools we know and love to deal with SQL. And SQL has been around for a long time, so the tooling has been developed over the years to be really nice. For example, I could be using a different IDE entirely to edit my SQL query. Here I'm using DataGrip, for example, which I think is quite nice for this. So say we want to make this a bit more complex. We only want the best 3 books for each of the genres, which is quite more complex than that. Let's make a subquery here. Let's call this ranking, and now let's only select those where the position is less than or equal to 3. I don't think a subquery is all that readable here, so we can ask the IDE again to change it to a common table expression, making it a bit more readable. And now we see a warning. Look at that. Avoid select star, that is overfetching data. We want to be precise about the data we're getting. And so we can expand this again. I'm not writing any code. Basically, it's the IDE doing this for me. Say we only want the genre, so we can select that, and the cover images, so we can do an aggregation here. So let's select the cover image, let's call this covers, and finally, let's not forget the group by genre. And there we are. We were writing SQL with a nice tool that basically was writing this for us, doing refactorings, showing us warnings, pushing us towards a good solution, a solution that is not overfetching data, for example. But now this is just a SQL query. How do we actually get to some Gleam code we can run? That's where Squirrel comes into play. So we first need to add it as a dependency of our application. I will not do that because I don't trust the Wi-Fi, so I've already done that. And then we can let it run and do its magic. And just like that, Squirrel, it's doing its thing, and as you can see, it can generate code for us. So let's have a look at what is happening under the hood, actually. So what Squirrel did was it generated a Gleam module here where, with the Gleam code that is needed to run our SQL query. And Squirrel is talking to the database, figuring out what our query is returning, for example. Here we can see that it could figure out that our query is returning rows that have a genre that is a string, and covers that is a list of strings. We did an aggregation, remember? And then it generates the function to actually run that query. And this code is exactly what I showed you in the slides earlier that we would have written by hand. What does that mean for us? Well, that we can just start writing our Gleam code and not care about any of that glue code because it has been taken care of. So we can call the query like a function here, passing in a database. Well, it's impossible to miss now that we're talking to a database. That is an argument of the function. And then we just start working on it as we would in our known and beloved functional programming languages. We pattern match on the value. So we see that something could go wrong. The database might not be there after all. The table might have been deleted by some poor intern on a Friday evening. So here we want to make some list, for example, and we list map over all the rows. Again, pretty standard functional patterns. I'm sure all of you are familiar with this. So we get the rows back, and then we turn each row into a list item. And let me import the missing things here. And since everything is nice and typed, well, we can ask the language, the tooling, the language server for help here. For example, we can see that rows is a list of those rows we were seeing earlier. We can jump to the type definition. We can see what shape of data we're dealing with. We can also ask the language server to generate the missing functions for us, to automatically pattern match on this data, to pull out what we care about. We can then start building things. So we can make a list item, generate the missing function again, and then fill in the gaps. So it feels really nice to be working like this, where we are just dealing with some data that we can pattern match on, work on the way we know and love. So this compiles, so hopefully it also works. Let's run it and see what this looks like in practice. So if we go here, okay, it works perfect. Might not win a design award, but it's pretty nice for something I could manage in 20 minutes. So, getting back to us, Squirrel gives us really nice developer experience because we're using the right tool for the job at each step. We're using SQL when we're talking to the database, and languages like Gleam, for example, while building our application. And since everything is in a SQL file, think about this. Your data is guaranteed to outlive any application you're building on top of it. So say one day you need to build something new. Well, you can just take those SQL files, they are there in your code, and start reusing them again in different projects. Say you get tired about Gleam and Squirrel. That would make me really sad, but you can use any other language and any other tool because your SQL is there, you own it. You're not being locked in to a specific technological stack, to a specific ORM, language, or query builder that might be also limiting you to a subset of SQL. Also, errors start happening at build time, even before we run our tests. The feedback loop is even tighter here. We don't have to spin up a test database and see tests go red before we can change it. If we give Squirrel a query that has some syntax errors, maybe is referencing a table that no longer exists, and so on, well, we get a nice error message here. Hopefully you can appreciate how nice that looks. Also, refactoring is a breeze. Say we change something. Of course we will, because our requirements change all the time. Say now the marketing team comes and they say, well, we need to actually make this parametric. So this is going to be fed in by the user. Maybe they want to see the 10 best books, number 1 best book, and so on. If we let Squirrel run again in our terminal, it's doing its thing, and now we start seeing build errors, because it's telling us that rank books now actually wants 2 arguments, and not 1. Can you figure out what the missing argument is? Well, that query parameter we added earlier. And so we get nudges and help, pointing us to all the places we need to update. Maybe we want to show the 10 best books, or it's some number that we get from the user. So we started from a place where we were thinking about the data we needed. We were writing SQL because we want to do that, but then we're stuck in this hellish loop where we are writing and maintaining glue code. We don't want to do that. And that's why ORMs are so appealing. They take care of those 2 steps down below. Don't think about the SQL, don't think about the glue code. That's really appealing. Though I think abstracting away the SQL is a recipe for slow applications, because we want to be in control of what is sent to the database, of what data we're fetching, with how many queries we're fetching that data. I'm sure anyone here who has worked with an ORM there among us might have faced the n+1 query problem, where all of a sudden your application grinds to a halt because you're running in a tight loop in your application some query without even realizing it. And so what does the Gleam take on this look like? What does a different take look like? Well, we want to write SQL, but we can let tools take care of the glue code. And so make the experience really nice for us, because we're using the right tool for the job at every step. We're writing SQL to talk to the database. We're writing in a different language, of course, to use the data and build applications, but we're not slowed down by glue code, heaps of that. We can still get a nice developer experience. And so that is why you do not need an ORM. My name is Giacomo. I want to thank you so much for coming here today and listening to me. That is all from me. Also, please consider sharing your feedback. If you liked this, tell me. That would make my day. If you didn't, tell me what you didn't like so I can improve next time. So please do that as well.
Thank you a lot. We have 3 minutes for questions. Are there any in the audience? Okay. There are many, pretty many, so just going to tell you, SwapCard application has a dedicated section for every presentation that has the Q&A section. You can pose your questions there. So if we can't squeeze them into these 2 minutes, I probably not. The speaker can answer them in the application. So, okay, I know who raised the, okay, the one closer, okay.
Thank you. A very simple question. Does Squirrel require running database?
Yes, it does, because to figure out what your queries look like, the shape of the data, the only source of truth for that is your database. So it will need some development database, for example, to be running, to have a schema that it can then inspect and see what it actually looks like. Yes.
Okay, thank you very much.
Welcome.
Still time for more? Okay.
That was very interesting,
Thank
first
you.
of all. I have a question. I imagine myself like introducing some new part of my app to, let's say, a front-end developer. The only missing part that I can see is that, for example, when I work with Acto, it's very easy to like show a schema. And the developer doesn't even have to like look into the table, look into the associations, SQL, all that stuff. You have any like tip for using that kind of thing and like reduce that boundary?
I'm afraid I'm not really all that familiar with how Actor is doing things, so I don't have like something I could relate to give you a suggestion. Maybe someone in the audience who has used that as well could help you later.
Thank you.
Okay, time for one more.
Thank you so much. Terrific presentation, really. It's been great. I was wondering how much of the modern SQL standard is covered by Squirrel and how hard it is to keep it on track, because we saw, I think, basic things like figuring out the return types, that kind of stuff, but I think it's much more richer, so I wonder how hard it is to keep.
That is a great question, almost like I planted it in the audience. Everything is supported, because Squirrel is not the thing that is parsing your query and figuring out the types. What it does is it sends the query to the database, to the Postgres database that is there, and then it sends back the information about your query, because Postgres sends a lot of information. So everything that is supported by your database is going to be supported by Squirrel. There's no subset of SQL that is only supported. There's some things that can be slightly harder to work with, because Postgres is not sending all the information we want all the time. So sometimes you might have to, for example, add a little annotation to hint to Squirrel, maybe to make something nullable. But besides that, everything is covered.
So it's essentially, just to understand, so it's sending information on a query and getting back metadata?
Yeah,
and building
exactly.
on top of that. Okay, thank you so much.
Welcome.
Okay, time's up. Thank you very much again.